Welcome everyone. Oh, I have to wait. Welcome everyone, all distinguished guests that are here today and also our viewers online. Welcome and thank you for attending this event. My name is Emmanuel David. I'm Executive Manager at Epfl Space Center, so the Swiss Institute of Technology in Lausanne. And today we're going to talk about sustainable space logistics, which is a research project that we are running at Epfl. Before starting, so I would like to introduce Dr. Somanath, that's going to give a few introduction remarks. He's the director of the Vikram Sarabhai Space Center at ISRO, the Indian Space Research Organization. So if you want to come.
Thank you for the opportunity to meet you, to talk to you. I also want to tell you that I have another hat. I'm the director of the Indian Institute of Space Science and Technology. It's a part-time job for me now, which is a university, deemed to be university under Indian Space Research Organization, creating capacity in engineering and science to feed to our space program, which just started 11 years back and doing well, and one of the important source of people for our space program, having aerospace, avionics, as well as physical sciences in like chemistry, biology, and mathematics, graduation as well as research. We try to do it with most of the Indian space research organizations, looking at the problems there and trying to do research. Also in humanities, looking at how the impact of space science and technology created benefits to the society also is one of the topics that we do address. Coming back to this, yeah. Okay. Okay. Thank you, Sudhir. So I know I'm here not to speak about myself, but more of what we can do together. I think that's very important. I'm really happy that we are having this program connecting to space. I really understand that you are trying to create that similar type of ecosystem within Swiss nation, and also to contribute to the European space program in general. As far as ISRO is concerned, we have a long history of cooperation with all the spacefaring nations. Started learning space technology from others. I must admit, the early part of our program brought the propulsion systems, the space launch capability, with the support of many other nations. Today we have a system ecosystem in India capable of creating applications down to the public use in a very large way. Also have the ability to build the spacecraft, the instruments, as well as do science. Of course, we have the launchers to do the launching. But the most important part is that the journey that we need to take further, it's really a challenging journey. We do realize that it requires much more global interaction and global presence, and we do have MOUs and agreements with various space agencies for joint programs. Some of them are joint research programs, especially looking in science, planetary science, exploration, joint development of payloads, etc. We also have exchange programs of students who go for research in various universities, which includes US universities in space. Especially from my institute, the toppers are deputed for their higher studies in those universities, and many of them come back and then contribute to our space program as well. We are also looking at space as an agency where ISRO can definitely collaborate in various topics, as you mentioned, one of them are definitely related to ecology and sustainability, which we have a series of satellites which is feeding to this program. We have specific instruments that look at sea. We have one which look at multispectral, hyperspectral. We have radar imaging which looks at not only for observation platforms for strategic reasons, but also have scientific capability built into those radar observations. We have a GNSS system of 7 satellites which also use for scientific research using those signals and characterizing the atmosphere and also look at various parameters that leads to the climate change research. We have planned to build more sophisticated instruments in spacecrafts for remote sensing. We also are looking at imaging from GEO. We tried one of the important payload but couldn't reach the orbit because of a launch failure. We are working on the next satellite to go. And also programs to go to Moon and Mars in a continuous manner. We are also looking at the next Moon mission where we are trying to do the landing once again that we nearly missed. And also working on the second Mars mission in terms of definition of the payloads, etc. And also one of the interesting an observation platform we are going to launch is the Aditya, which is the study of the moon, helio interactions with Earth, and also to look at how the solar activities are affecting the space weather. Also want to tell you that we are having a serious programs to look at space debris, and we have created one office of the directorate to look at space situational awareness in a big way. Creating one of the observational platforms, at least in the optical domain, to look at and catalog and also add to the global data on space debris, and also making use of some of the global data to make better predictions and models for safe space exploration. So these are some of the things that we do. We hope that with you and with the Swiss federal agencies as well as the university that you are, I believe that we will have a greater way to interact and then know, especially at the scientist level and students level. Thank you so much.
So thank you very much for those introduction remarks, and I want also to note that so Indian-Swiss collaboration also goes back because the first Swiss satellite, Swisscube, was launched on an Indian rocket, so back in 2009. So our next distinguished speaker is Tim Florell from the European Space Agency. He's the head of the Space Debris Office, and he's going to give us a short introduction on his activities and on the space debris situation.
Yes, thank you, Emmanuel, for the nice introduction, and good morning, everyone here in Dubai, and also good morning out there in the internet. Yes, it's a huge pleasure for me to be here today and to introduce a topic that is really close to my heart and what we are doing at ESA as well, which is space logistics and the relation to space debris, which is my daily life for many years already. We all know it, and you have heard this already from ISRO in the introduction, that what we are now doing in space and how we use space is an indispensable part of our daily activities. Space is everywhere. We are using space knowingly or not knowingly every day, multiple times. A friend of mine assessed, just as a joke maybe, how many of his apps on his mobile phone are using space infrastructure or space data, and it was more than half of them, and Candy Crush was not among them. So really what I want to say is we are observing an enormous change these days. We are part of a transformation towards space as a commercial resource. And how did we get there? Well, we are launching satellites now since 1957. This is not a secret. And if we look into our records, we see that we did about 6,000 launches. And these 6,000 successful launches, or more than that, placed 12,000 satellites into orbit. Out of these 12,000 satellites, 7,500 are still in orbit. And out of those, and this is the big number to keep in mind, more than 4,700 are active. And if I think back some years ago, there was always the number of around 1,000, 1,200 active satellites just a few years ago. And now we have 4,700. And the forecast, if you look in the next years, will continue like this. We will be launching more than 1,500 satellites every year. And this is more that we had active in total just a few years ago. So you see the drastic changes that are coming. How do we know all this? Yeah, you heard just about this. There's space surveillance, and in space surveillance we are building and maintaining catalogs of the objects in space. And from those we also know about the problem of space debris. And space debris mainly goes back to more than 500 fragmentation events that we know of. These are collisions and explosions mainly that have happened. Some of them very severe, creating thousands of fragments. Some of them smaller, creating only few. But they have happened. And from what we placed into orbit, we have to face it that also fragmentations will happen in the future. Yeah, and that places more debris, and more debris can create more fragmentations. And that's a situation we have to deal with, and we have to manage it properly. At ESA, we are building models to help the design and operation of spacecraft in a sustainable way. And our master model predicts that from statistical surveys, we have now more than 36,000 objects larger than 10 centimeters in orbit. And if you go to 1 centimeter objects, already more than 1 million objects. And even a 1 centimeter object has enough energy that upon a collision could render your satellite unavailable. And if it's more than a few centimeters, it may lead to a fragmentation again. This all, and allow me to point you to a report that we do every year. You can read in our environment status report that ESA does. It's really available on our website, and it's a very complete compendium of statistics, graphs, and numbers that you may want to look up. So, seeing now that all orbits are becoming more congested and contested, what can we do about this? And there are solutions, and we will hear about this in the talk today. One thing that is critical to understand that orbits are a natural resource of a limited capacity. And using this capacity wisely is our goal. And this all leads to the overall goal that we have to avoid a space debris crisis to happen. Another crisis on top of our crisis is not what we can afford. And I may point that there are space debris mitigation guidelines out there. There are, at the UN level, there are voluntary goals that have been established in 2019 already. And they all are very good in outlining what can be done. One thing we should not forget about it, all these what can be done relates to costs in the design of the satellites, but also in the operation of satellites. And coming now to something I do daily is I'm responsible for collision avoidance at ESA satellites. And I can tell you from the daily life, this has changed also in the last few years. We often saw close approaches with debris satellites, but now the things are getting different. We are seeing more and more close approaches that we need to take care of with active satellites. So where there is another operator. And this changes the picture. Because if this is a debris, it's clear, you have to avoid. But if it's another operator, it raises a lot of questions. What are the capabilities of the other satellite? What are the plans of the other operator? Are there changed plans? Are they maintained? And you see, this all requires, at the moment, manual coordination. And speaking to my team, they are not happy to do this coordination during the weekends because celestial mechanics essentially doesn't care about weekends and holidays. And automation is the key there. We have to get digital there. We have to automate. We have to use technology that is available outside. Machine learning in decision processes is something that we are looking into. And automating collision avoidance in the support of coordinating space traffic is a technology goal that also ESA follows in the space safety program that we have. So that's why I'm super happy that I can introduce now our speaker, Professor Jean-Paul Kneipp. He's a full professor for astrophysics at Epfl and the director of the Epfl Space Center. And he will introduce now how sustainable space logistics can help me in my problems. And also what is done in activities at the Epfl Space Center. Jean-Paul, floor is yours. Thank you.
Thanks, Tim, for the introduction, and it's a pleasure to be here and to give you my speech about sustainable space logistics. So, let's see, I have a few slides, but hopefully we'll have some interaction also. Something not working, or maybe I have to do something special. Oh, it was on not on, okay. Maybe you can help me there? Okay, maybe I'll just introduce myself. I'm a professor in astrophysics at Epfl. I've been at this university since almost 10 years now. And I've been, basically, my research in astrophysics is about mapping the universe. And when I say mapping the universe, is really understanding the distribution of galaxies in the universe and what they teach us about the universe. And when I do that, I'm collecting a lot of data, data from the sky, from the galaxies. I'm doing that with imaging data, but I'm also doing that in spectroscopy. Okay, no, it works. And so I'm constantly basically looking at the sky. And when you look at the sky, the first things you do when you take an image, you will remove all the defects that that are in your data. And more common defects these days, is satellite tracks. And so I decided to develop maybe a line of research, and I will talk about it a bit later, about monitoring these satellite tracks based on astrophysical data. A couple years ago, in 2007, so 5 years ago, I became the director of the Epfl Space Center. And at that time, there was a lot of development being done at Epfl about what is sustainability in space and how we can make things better. And so I arrived there and I started a new research on this topic. And main research topic we've started only 2 years ago is what we call sustainable space logistics, and trying to understand, we can make space more sustainable, and that means, you have to think differently. But let me just introduce a few numbers from an astrophysicist perspective. Okay, people like to think of, possible travel, interstellar travel to find a new home to live, etc. What I want to say here is there's no planet B. The Earth is our spaceship and it will be forever. And this despite a large number of galaxies, about 200 billions in the universe, and in each galaxy there's about 100 billions of stars, and around each star there are typically 7 to 10 exoplanets. So it's not like, our home is unique. Certainly it's not. But the distance between the different systems are really huge. Universe is really huge. If you take just the nearest star, which is 4.3 light years away, if you turn that into kilometer, it's 40,000 billions of kilometers, right? So maybe that doesn't tell you very much. So then I looked at, maybe you heard of the New Horizon space probe, who came to Pluto, which is like the border of our solar system. It takes 10 years to go there. If you go at the same speed up to the nearest star, it will take you about 50,000 years. So, 50,000 years is more than, the Homo sapiens in on Earth. So it's just something, you can just think of something like that. And I wanted to point also this picture regarding sustainability and trying to put the context of sustainability into space. Our planet Earth is a spaceship, and it's a spaceship, so it has a limited size. We can measure very well the diameter of the Earth. We can measure the landscape, etc. So the fact that the resources on Earth are limited is just that the Earth is limited, right? It's not infinite. And also, all the issue about sustainability we face today is about these limited resources. Okay, and that is a nice plot of the Earth overshoot day. The time in the year you basically spoil all the production on Earth. That's been, in 1970, it was about at the end of the year. Today is more like in August or something like that. So we could, explain sustainability by this lack of resources. And so then I bring this question to you. Are current space activities sustainable? And if we just follow what teams say, maybe there's a problem. And I'd like to link this problem to the orbital resources that are not infinite, right? This is kind of a picture of the Earth. Sorry, oops, I go too fast. With all the satellites that are tracked today around the Earth. So there's active satellite, but most of them are debris here in these pictures. And you see them, different location. You see them at very low Earth orbit, so very close to the Earth, only like 600, 700 kilometers from the surface. And then you have all the more distant satellite up to like 36,000 of kilometers in the geo orbit. So I think we have a problem, and I like this sentence, Houston, we have a problem. And this is also linked to the fact that space has been turned into, a commercial aspect, which I think it's great for humanity, but it also comes with some cost, right? And I think this is the big problem is also especially at low Earth orbit because you have a density of satellites which is much larger. The problem is at every orbit, but specifically at low Earth orbit. And this is also an issue because there's more and more of these large constellations building up. So low Earth orbit is really a nice place because you're very close to the Earth, you have a very small latency of communication, you have a better resolution of your images if you look at the Earth for like observation. But of course, those orbits are rare, or at least they're not unlimited. And so we have to think about, what we should be doing to make this possible and keep using these orbits. But so we have to try to think differently. And I want to say also here that the space debris problem is, cannot be denied. I think it's a common understanding. And it's also something that could be a big issue. This is the video that was taken at the Crew Dragon separation of the last stage of the rocket, and you see that during the separation you have this debris passing by, and this was not planned, right? This is something that had just happened. Nobody could have planned it. The debris is very small. It's not going very fast because it's more or less going in the same direction as the orbit of the rocket. But if he were going on the opposite direction at 7,000 kilometers a second, you would not be able even to detect it in this video because the time frame of the video is like only 20 or 25 per second, right? So this could be also problematic in the future for human space flights, and so we should really be aware of that. So why EPFL is motivated in doing this research? Well, I guess it comes with taking responsibility of what we've been doing. And what we done in 2009 was launching a Swiss cube. And you see the student in the middle picture that made this CubeSat. And we realized after launching it that we put the satellites at 7,700 kilometer altitude. At that altitude, a satellite will stay forever on your time life, basically. And so it will never go down. Okay. And although the Swiss cube is still active today, we can still communicate with it. Right, we cannot change its orbit. There was no propulsion on the CubeSat. And so we had a project starting in 2010, 2012, to think of an idea of a system that would go and grab the Swiss cube. Okay, this project is still not going on anymore because we have another bigger project, which is cleaning one of the ESA space debris. And that's probably better to start with bigger debris than small debris because they're more problematic. They have a larger cross-section, so they could have a bigger impact if they collide with some other things. But when we did this research, we were developing all the softwares, all the ideas, the capturing system that could make this possible. And following these lines of research, we started 2 years ago a research project which we call Sustainable Space Logistics. When you think of space, you have a lot of activities. You launch things from the ground to space. You could think of capturing things. You could think of in-orbit servicing, like refueling your satellite, making life longer. So there's many activities you could think in terms of logistics in space. But we wanted to push the sustainability part because we really think that's something we need to think about in the future. And you see one of the project, the Avoidance project from clear space to remove the ESA space debris here as a picture. Or you could think of also the reusable launcher with the SpaceX booster here. So we have to think in the future in a more sustainable way. And so we try to develop this research activity at EPFL. I want to show you a few slides about the current status, as Tim was saying, and I think the number is keep increasing. He quoted 36,000 space debris larger than 10 centimeter, 1 million above 1 centimeter. And you see when this curve started with Sputnik in 1957, it just kept growing. And you see the different system you have, and in particular you have the rocket body, which is usually the last stage of your rocket that stay in space. Now people are really trying to put that last rocket stage back to Earth, but at the beginning we didn't really care. So there's a lot of rocket body flying up there, and those are really big in general. So you really, if you have to start cleaning up, maybe you would start cleaning up the rocket body, if it's possible, because they're huge and they're massive and they have a large cross section, and that they could be giving a lot of damage. Here is what could be the situation in a couple of years if you believe what's in the press about the many constellations that are planned to be launched in the future. If you believe this picture, there will be many more satellites in a couple of years that we have today. So the situation of space traffic and space debris will be getting worse with time. So maybe this will not happen, but if ever it happens, that would be problematic. So what are the challenges? And I list a few of the research lines we're working on. You could always ask yourself, is there a problem? Right. It's difficult to look at satellite from the ground with your eyes and realize that there's a problem. So what I think is important is to keep monitoring the situation, but keep monitoring the situation in an open way so that everyone can access your data and that there's a common agreement that the important information in that data is shared with everyone. So I think lots of people are doing these observations, but sometimes not so openly, and that limit interaction and limit understanding of the problem. So I think looking at it in an open way is really something we should be, as human, consider very seriously. So well the problem is known. Okay, if you're a space addict, of course you have heard of it. But if you have just a user of space through your smartphone, well, you don't really know what's going on. Okay, just because the communication doesn't go everywhere, or at least not so easily. So I think it's important, and as a university, we want to educate young people about it. And it's also important because there's more and more new faring countries to also educate those countries because, of course, they see like space like the next frontiers, but it also comes with things and constraints, and they should understand those constraints. So I think it's important that you share the communication around you also. So also, we need to change the way we design satellite or design a space mission, in the sense that, as I was saying, you don't want to put more rocket bodies in orbit. I mean, you want to make sure that your rocket body just come back to Earth and be destroyed. And when you think of satellite constellation, you maybe try to think of or let's try to minimize the number of satellites in my constellation and not just, put as many as I want because, it's great. No? So you have to think differently. And so, that's a bit of thinking, design thinking that you need to do. What also is important, I think, is rating our capabilities of our satellites. And here, what we, and I will discuss that a bit more in detail after, we had this space sustainability rating that was started by a number of universities and with support of ESA to rate a satellite or a mission or a launcher or a launching company to make sure that they understand the problem. And we will grade them, give them a rate, whether they're excellent, they understand the problem. That would be a great one, and if not, then maybe there's going to be more interaction with them, trying to educate them basically. And it's also for us a very good way to monitor how good we are doing in terms of launching rockets. Launching satellite in a good way. And of course, which is also a very visible project, is that today nobody can, go and do the cleaning because there's no garbage truck in space, right? That doesn't exist. Okay, so we have to prove it that it's possible, and when you've proved it's possible, then of course you can go and talk to people and say, okay, you have lots of debris up there. Maybe it's time to clean up, and here is a service. So developing a service to clean space is something very important, and we have this Clear Space startup from Switzerland that is aiming to clean one debris Of course, cleaning one debris will not make a difference, but showing you can go and clean debris, it's the first step to have kind of maybe a market after, but certainly services to other countries. And of course, this is all about technology and thinking, but you also need to put that in kind of space law, maybe at a nation level, because it's there where decisions are made. So we try also to develop communication at nation levels and with different actors, so that they are aware of the problem. So this is a bit more of my daily data set I'm looking at when I look at distant galaxy in the universe. So these are two different frames separated by 10 seconds in time. And what you see in yellow are satellite tracks that are crossing my data. So my data is not really about observing satellites, it's about observing galaxies. And what you see, the field of view here is 1 degree by 1 degree, so it's typically 4 times the size of the moon on the sky. So I'm having these very big images on the sky, and I have those satellite tracks passing through. And you see the typical exposure time here is only a few minutes. So that means every minute in front of my telescope there will be one satellite passing through. And well, if you were getting very close to the data, you could see the rocket body of Ariane 2 there, and you would see it fluctuating in fluxes. So that means that rocket body is probably rotating very fast, and we estimated that the rotation was about 1 turn per second. So this particle debris would probably be very difficult to remove just because of its rotation. If you want to grab a satellite that rotates very fast, then it's very complex. But you have other satellites that don't rotate so much, so those can be removed. Yep.
Last slide, there's one frame coming from the top left to down. Is that another satellite?
You mean this one?
No. Could you please repeat for the audience? No. In this image.
In this image.
That image, sorry.
Yeah.
Top left, first block.
Yeah. This one.
Down. Is that also a satellite?
Yes. That's a satellite track.
That's another one.
That's another one. The one could be identified in the database, open database, are indicated in blue or yellow, because we know they should be there. But of course, we're detecting debris or satellite that maybe are not catalogued. Because some of the public catalog, you don't get everything that exists. You only get part of the data. Like if you look at the US catalog, there's a number of military satellites that are now listed. So that's the thing about openness of the cataloging, which I think is super important, because if you don't have the right information, you cannot tell all the story. Regarding better design of satellite, we have a PhD student working at Epfl trying to rethink the way we're building satellites. And one of the ideas that you kind of see here is to use some pattern languages to develop a satellite and a space mission. With the idea that when you think of your orbit, so that's kind of a description of your satellite being launched and going to, in this case, going to the moon. And of course, you will get rid of the last stage of your rocket and things like that. And you see the different colors And the idea here is to really think when you develop your space mission, to think of all the components you're launching in space and what they will do in the future, right? Of course, the thing you want to put on the moon will go to the moon, but what about all the other things that allow this to happen, right? And are they going back to Earth and burn into the atmosphere, or what you do with them? Maybe, you know, depending, you know, at the stage of the mission, you can also, you know, put it in an orbit that goes very far away, and then it's fine. But really, the idea to think a bit differently and think about all the stages of your mission. And using these pattern languages is an interesting way, because you can look at different aspects. You can compute the risk. You can compute the mass to Leo, which, you know, very closely linked to cost. But you can also do some kind of rating estimate of your space system. Other activities we're doing in terms of research is about developing the technology that would, for example, in the case of clear space, made the capture possible. So capture is about robotics on one side, but it's also about vision and recognition of your satellite that could be rotating. So because you have limited, you know, data transmission, you have to do a lot of onboard computing and image recognition of your satellite. So that's a lot of things that are being developed. You should think also of how you build your satellite so that when you enter back to the atmosphere, it's completely destroyed. So we are looking with the material lab about how you best build a satellite and things like that. And regarding the space sustainability rating, so this is an idea that was started in 2018, launched by the WEF, and also UT Texas, MIT, Bryce Consulting, ESA. And they develop a way of rating a satellite or a mission. And to implement this rating, they had an open competition, and we basically compete to implement this rating, and we've been selected. That happened this year, and hopefully starting next year, we'll start to put things in place. Hopefully, oh yeah, sorry, I need to be here for the camera. And then we can basically share this rating to the community. So we currently have some beta tester, some company who are testing the rating, and we're working with them to understand how to put this in place. And hopefully this, in the coming months, will be effective. And of course, the first garbage truck in space, the Clear Space mission. The goal here is to launch the space mission in 2025. But of course, to reach this goal, there's a lot of things still to be done. Building the satellite, building the robotic arm, building the intelligence behind the system. So that's kind of a race because 2025 is very, very close in time. Okay, and the final point is about communicating and engaging with different actors. And we had a Sustainable Space Logical Digital Symposium early this year, and we continue to bring information to the community and share perspective view of each of the partners in this space activity. Right, so what if we were doing nothing? As Tim was saying, we constantly rely on space. So that's going to be a big challenge if space is not available in the near future, and would have a big impact on human society. So to finish, I just ask yourself, so what are you doing for space sustainability? We really need to think about it in a common way, and I think it's good to have questions and discussion about it. Thank you.
So thank you, everyone, and thank you, Jean-Paul, for this presentation. So if you have questions, it's also time. I also want to remind if there is any live viewer on the internet, you can ask also questions on the chat on the YouTube channel. I will take also a few of them afterwards. But so I have one question there, and you have a mic coming.
Thank you, Professor, for your wonderful talk. We in India, with guidance of ISRO as a startup community, we ensure that any hardware going to space has sufficient delta V capability to deorbit at the end of life. So that's a step we together are taking. That's a message which we would like to give to you. On the other hand, it's a personal question to you as an astrophysicist. Looking at the, all your observation is land-based. With the telescopes, the 30-meter telescope coming, everything. But with so much of thousands and thousands of satellites going up, how would it affect science?
It's a very good question. I mean, in general, I would say in optical astronomy, the density, or at least today, the density of satellites is not such of a problem. As you see in that big images, I mean, so we have a few. Of course, when you have a track, everything below the track, it's like a loss of information. Okay, but usually when we do a data acquisition, we have multiple images of the same place in the sky, and so instead of relying, like say, at 4 images, then we rely only at 3 images at the place where you have the satellite passing. So of course it's a problem because your data quality is not as good, but we can mitigate the problem in the sense that by taking multiple images, we can get rid of the problem. So in optical astronomy, although it's a problem, and but we can deal with it and we can mitigate the problem. In radio astronomy, that might be more difficult, and especially when you work at higher frequency. And especially with these, very large number of satellite communication. We are building radio telescope on the ground in places where there's very little communication system. So, for example, the SK project will build a telescope in South Africa and Western Australia, where it's a desert land and there's very little communication because there's no one, basically, right? But in fact, there's going to be lots of people, let's say, our communication system with these many constellation of satellites that are trying to provide 5G internet. And this is more an issue because it would be very difficult to have those satellites just avoid passing above the radio telescope. So for this reason, I think the problem is more critical in radio. So of course, radio, communication is done at specific wavelengths, but if there's so many satellites with their own wavelengths or own frequency of communication, then basically that erases quite a big window in the radio frequency that you cannot observe to observe the sky. So that's more of a problem than the optical astronomy.
Thank you so much.
Yeah, thank you for the excellent presentation. Just my question is because nowadays when we are talking about the many satellites, the solution is coming up with very small satellites, CubeSat type of things. But this is more and more debris. That is another problem.
Yeah.
So whether we should go for small satellites or bigger satellites with the less number of satellites with the more sensors, how to go about it? First, this is one question. Another question is regarding your garbage truck. It is really what type of sensors you are producing? It is a attractor type of things, or it is only a robotic arm type of things? Because attractor is then it is much better to have such solutions, I think. Thank you.
Okay, so there's two questions. First one, whether you should design a small or bigger satellite. Well, it's a very good question. I don't have the answer. I think one has to do a study about it. I just don't have the answer. I mean, that's clearly something as a design phase. I think this is something very important to do. What's the best? As the second question, can you hear me again? Oh, yes. Yeah. Yeah, so at the moment what we've been developing is something which will just grab the satellite. But I understand effectively you could think of a different system. But of course, for debris that are up there for a while, that were not designed to be, tracked back to Earth, there's like no magnet or nothing. So they've not been designed to be, attracted, through magnet or whatever. So you have for these old system to have a, grabbing system. I think there's no other way. But effectively, for the future, if you think of these constellation, people should be thinking also, if I have that many satellites orbiting, I will deorbit them, either with propulsion or with kind of another type of truck. But then maybe you should try to develop your satellite in such a way that it's easy to be grabbed, basically.
The ground system will be tracking and the robotic arms in the space will be grabbing, because normally the lidar and these are the new techniques that's coming up. The satellites itself will track the grab even a small 1 centimeter by 1 centimeter also, and that intelligence can be embedded into the tracker, and the tracker will drive the robotic arm and grab it, because a lot of synchronization,
exactly,
the location parameters have to be synchronized. So what kind of that synchronization, telemetry, tracking, etc., are incorporated in your space?
The system we're developing should be autonomous, in the sense that we don't rely on observation from the ground. Of course, we rely on observation from the ground to make sure that the orbit is correct, that the satellite may not be rotating too fast. But in terms of the capture, it should be fully autonomous. So there will be a radar system to locate the satellite. There will be lidar system to, when you get closer, and to measure exactly at the distance, and a camera to recognize the rotation of the satellite if it rotates. And then there will be an automatic grabbing system.
Second is, are you open for discussion? Some of the startups, as is telling in India, they're interested in the debris management, both the tracking and mitigation. Are you interested to open a discussion with them?
Yeah, I think it would be.
We will divert them.
Yep.
We will divert them.
Yep.
Thank you. Thank you.
There's a question here. Vincent.
Two questions.
Two.
First is, once you grab the satellite, what are you going to do? Are you going to bring it back or push it to something else? And second question would be, how do you capture a small size of debris? Because are you going to squat them like mosquitoes or something like that?
Yeah, so for this first demonstration satellite mission, the idea is to just bring back to the atmosphere and crash everything into the atmosphere. So both the chaser that grabbed the satellite and the debris itself. So everything will be hopefully burnt when going through the atmosphere. But of course, if you think of, a real service that could be developed in the future, that doesn't make sense in the sense that, it would cost too much as a service. And so the future idea, which is not developed for this first mission, is to have a kind of a truck that go and grab your satellite, lower it down to, say 400, 500 kilometer altitude, and then go and fetch another one and do this many times. But there's many different options to be think about it. But that's one of them. Certainly, if you want that the service applies, of course, it will have some robotic arm of some dimensions, so that means you cannot also you have to scale your system so that you can capture only some kind of satellite. You cannot, if you want to go for CubeSat, the system should be different than if it's a larger piece of hardware. Sorry about that. So did I understand you? I mean, answer your questions or? Yeah. No. And I guess you probably have to adapt your system depending on the size of your debris.
Very good afternoon, Professor. It was a nice presentation and discussion. My point is, as you mentioned, orbit as a nature. And is there any policy as such we can bring in that every company, you told in 2025, nearly your service will start for deorbiting things. So you also mentioned that you will go and ask each and every companies for the services. So the question is over here, there is any policy we can have it or is already available? I'm not too sure, but while people launching the satellite or launch vehicles in the system, so they should have, as it is an ongoing journey, they should have a return ticket of bringing it back before launching it. So is it possible like that?
Well, ideally, I think it would be great if such a measure is in place. I guess as of today, there's no such things. But it's also the fact that, if you don't have a garbage truck, then your garbage just piling up, right? And you cannot force anyone to have this garbage pile up because, well, there's no garbage collector, basically. But if you demonstrate there's a way to, clean space, then of course the mindset will change completely, right? Or at least hopefully it will change completely. Because then, things are possible. And then people have to think differently and have to think of a way, either, bringing back by enough, propulsion back, allowing your satellite back to Earth, or if it's just impossible, or if you have a failure of your propulsion system, then maybe you could benefit of the service.
It's not a question, it's an opinion. It's an excellent idea as a demonstration. It definitely will be an inspirational part. I just want to tell you, there are many young boys and girls are really aware of this the issues of debris, and they are writing to us because we are in the space domain. I am getting mails from young boys and girls on how to overcome this, and they're given me paper sketches on how a recovery satellite to save debris can be done. But many of them really don't understand the fundamentals of this. It may be okay for one particular debris to be returned by one particular chaser. The energy required in moving from one spacecraft location to another is tremendous.
Yep.
And it requires a huge amount of propulsion capability to move even a little bit of orientation, or we call it the inclination.
Yes.
And also the altitudes and different directions.
Yep.
So to have a general truck that will go around and collect the debris and bring back, it may be a very difficult proposition to start with. At least this idea to demonstrate it is good, but then technologies need to evolve for a long-term return. I fully agree that we need to have an auxiliary propulsion as part of every spacecraft, which at the end of the life of the spacecraft will take on the whole journey, including an inertial system which will come on.
Yep.
It'll propagate the state vectors from the prime mother satellite to this, and then take on the further journey of deorbiting or returning back to Earth. This is the only way for at least for bigger satellites to be deorbited. The other means are only evolving, and it is more economical and energy efficient way of handling future debris to come. But what is to be done for the one which are going to the orbit now, the 1,500 numbers per year, we need to be really worried about. Like the ecological disruption that we are doing, it is similar to that we are making it until humanity realizes that it is a very serious issue.
Yes.
The actions may not really come up in big way. But at least your idea and your proposal to have such a launch really inspire, I hope it will inspire the generations. Thank you.
I'm grateful of your comments. I really share your views, and I think effectively, there's a lot to be done, and there's probably a different way to do things. And effectively, one of the issue is changing the inclination of your garbage truck. So maybe you could think of having different garbage truck for different type of inclination. So, the idea is to open basically, a way of thinking differently and propose solution. And I don't think there's only one solution, and I would be very happy to see other, countries on Flying Nation doing this kind of thinking and sharing their ideas.
We have a question here. Maybe it's the last question.
Yes, it's not a question, just an idea about if we were to make it mandatory in every satellite to have certain amount of reserve energy and what we call as a homing point from wherever it might be. Once it hits this reserve energy level, then it has to go to a designated, let's call it as a waste paper basket kind of a place. If we make that as a policy that every satellite must have these two put into it, will there be an easier solution? From there on, we need to send the truck only to one point.
Yeah, I mean, certainly if you design your satellite to have, enough energy to bring it to lower orbits, like, 400 kilometers, for example, and then after, a few orbits around the Earth, it will decay and go through the atmosphere. Certainly, that's a solution. I guess one of the issue is that, are you really going to, or a service provider, are they really going to use this fuel for just doing that, or just to extend the mission? Okay. But yeah, I mean, certainly that's the way to go. And it's certainly, if every satellite has a propulsion system to allow, re-entry.
Because otherwise today, every satellite is a one-way ticket. It's up there.
Exactly.
And we need to build that return ticket into it.
Exactly. But of course, you could have also a failure of your propulsion system, right? Or your satellite could be hit by a debris, and then your propulsion system doesn't work anymore. So certainly that's the way forward, but it doesn't probably solve every problem.
Thank you very much for the audience and all those questions and its interest. I think with some of you we will be able also to continue the conversation. And I also wanted to thank also our viewers online and wish you also a lovely day. I don't know if Dante, maybe.
Yes, thank you very much for this fascinating presentation. My name is Dante Darini. I am project manager here for the Swiss Pavilion. It was an honor to receive you all. Now I would love to continue the conversation with the speakers and yourselves. So we have to vacate this room. However, we have okay. We have a VIP area.